Since we're having so much fun with trigonometry, let's continue. So really, my goal here is to look at the values of sine, cosine, and tangent in quadrants 1, 2, 3, and 4. If I was being more specific, I'm hopefully, after our little discussion here, is that you're able to identify whether sine, cosine, and tangent are positive and negative, and in which quadrants they are positive, and so, right? Like which quadrants they are positive and negative. So let's just recall a really super important fact. The important fact is these definitions right here. Yikes. Now I've drawn attention to these definitions in blue. Just going to get rid of the blue highlighter. Sine theta is equal to y divided by my radius vector r. Now, what you have to keep in mind is that your radius vector r will always be positive. Cosine is x divided by my radius vector r. Tangent is y divided by x. So allow me to pick a point in quadrant 1. Now here's a point, and this point I'm going to say is x, y. So sine theta in quadrant 1, what we know is using our definition is that the y is positive, and my radius vector r, distance from the origin to that point, is positive. So sine really is going to be positive in quadrant 1. That's an important fact. Cosine in quadrant 1. Cosine is x divided by my radius vector r. What I notice is x, the x coordinate, is positive in quadrant 1. My radius vector r is also positive, so my cosine of theta is also positive in quadrant number 1. Last but not least, tangent. And here, tangent is y over x. Now, my y coordinate is positive, my x coordinate is positive for all points in quadrant number 1. So therefore, my tangent ratio for all quadrant 1 angles is positive. Now, also recall that our tangent can also be a measure of slope. This is more of an idea than anything right now. So what is the slope of this line? Well, any line originating at the origin and going into quadrant 1 will have a positive slope. So what have you and I have just put together? We have just put together in quadrant 1, sine is always positive. In quadrant 2, cosine is always positive. In quadrant number 3, take that away. Talking quadrant 1. In quadrant 1, sine is positive, cosine is positive, tangent's positive. So this is what it looks like in quadrant number 1. Let's move on to quadrant number 2. Now a quadrant number 2 it looks like this. And the terminal point here, or a point on the terminal arm, is x, y. Now, is x positive in quadrant number 2 way over here? Is your x coordinate positive or negative? Well, I'm hoping that you're going to say your x coordinate is negative for all points in quadrant number 2. Your y coordinate is always positive for any point in quadrant number 2. So x's are negative, y's are positive. Your radius vector is always positive. So let's just deal with this. Sine. Your sine theta. Your y coordinate in quadrant 2 is positive, and your radius vector is positive. So sine theta is positive. What is the sine of 131 degrees? Well, since 131 degrees is in quadrant 2, I know that the sine is going to be positive. Let's continue on. Cosine of theta. Now, perhaps I should put a little subscript 2 here. That didn't work too well. Anyways, cosine of any angle in quadrant number 2? Well, cosine is the x-coordinate. Well, the x-coordinate in quadrant number 2 is negative, divided by my radius vector, which is always positive. So the cosine of any angle in quadrant number 2 is going to be negative. Now, how about tangent? Well, I'm sure some of you guys are able to look at that line and say, oh, that's a negative slope, so your tangent's negative. Absolutely. Or we can say my y value, since tangent is y over x, my y value is going to be positive, my x value is negative. Overall, in quadrant number 2, my tangent value is negative. Now, I'm just using that subscript to denote that we are in quadrant number 2. There's nothing special about it. And that should say tan and not tax. Let me just fix that up. And by fixing it up, I mean probably make it worse. There we are, tan. I'm going to press pause here. I'm going to let you work on quadrant 3. Here we are. I'm starting. This is what I got. My x and y coordinates are both negative. So my sine ratio, now my sine is my y over my radius vector, and it's a positive or a negative divided by a positive. So in quadrant number 3, my sine is going to be negative. Similarly with cosine, my x-coordinate is negative divided by my radius vector is positive. Overall, the cosine will be negative. Now tangent theta. Now this can be a little bit tricky. The tangent theta, since y is negative, the x is negative, tangent theta, therefore a negative divided by a negative is a positive. Also, you may want to look, what is the slope of this line? Well, that's a positive sloped line, so that gives us an indication that our tangent is going to be positive. All right, there we have it. I'm going to press pause. You do quadrant 4. All right, so in quadrant 4, what does my angle look like in quadrant 4? Well, if the angle is positive, it is measured starting from the initial arm all the way to the terminal arm. So we might be talking about an angle 320. It's a big angle, almost one full revolution. Regardless, any angle in quadrant 4, what I'm getting is the sine is the y-coordinate divided by my radius. So what we have is my x-coordinate and my y-coordinate. Now, my x-coordinate is going to be positive, and my y-coordinate is negative for all points in quadrant number 4. So no matter what angle you're dealing with, well, this will be true. So my sine will be y over my radius vector. Since my y-coordinate is negative, my radius vector is positive. Overall, sine will be negative. Cosine, a little bit trickier, no doubt. Cosine is positive divided by a positive. The x-coordinate over my radius vector, both those are positive. So a positive divided by a positive is a positive. The tangent of theta is equal to negative, or tangent is y divided by my x. Since my y is negative, my x is positive. Overall, in quadrant number 4, and tangent will be negative. And whenever you are trying to, this is, in math, I don't like rules, and I know that probably there are some whispers around the universe that there exists this cast rule that tells you where things are positive and negative. But really, let's get greedy and try to understand what's going on. Sine is going to behave, if we look at sine, since the denominator is always positive, sine will be positive or negative wherever y is positive or negative. Very easy. Quadrant 1 and 2, the y's are positive, so sine is going to be positive. In quadrant 3 and 4, the y's are negative, so therefore the sines are negative. Easy enough. Cosine is x over radius vector r. Now, my radius vector r is also positive. So really, cosine behaves similar to x. So wherever x is positive, cosine will be positive. Wherever an x is negative, cosine will be negative. So cosine is positive in quadrant 1 and 4. Negative in 2 and 3. Now tangent really mimics slope. Our terminal arms, where are terminal arms positive, have a positive slope? In 1 and 3. Where do they have negative slope? Well, in 2 and 4. There we have it. That's how I'm able to tell whether sine is positive or negative in which quadrant. First thing I need to do, I need to identify the magnitude of the angles. Second thing I need to do is I need to be able to differentiate whether x is positive and negative and the slope and all of that and put those pieces together.